Here example 1. Okay, with the requirement of, let's say, 50 host example by using method of FLSM. So first thing, my requirement is here 50 host, right? So what is the formula? So the formula will be 2 power h minus 2 greater than or equals to requirement. So what is this minus 2? In each and every network we don't use two addresses. One is network ID and another one is broadcast ID, right? So here
yes,
requirement will be 50 minus 2. So here 2. And what is the h value? H value is nothing but your 2 power table. Okay, so if you go back and see this 2 power table, what is the nearest possible size? So my requirement is here 50.
2 power 6.
So if I go with 2 power 6, it was satisfying my condition where it is going to be supported around 64 addresses. But if I go with 2 power 5, it was supporting only 32 addresses. But my requirement is here 50, right? So then we need to go with here 2 power 6 value. So here 2 power 6. So 2 power 6 is nothing but 64 minus 2. 62 will be your valid IP addresses. Okay, so this is the first step of calculation. So in second step, we need to find out the subnet mask information. So in order to find out the subnet mask information, we need to decide what class of address we need to use. So we have here three different classes. One is A class, B class and C class address. So my requirement is here 50, right? So I can go with here C class. Okay, so in C class I have 3 networks and 1 host portion. In order to be the same network portion has to be same. Host portion, it can be anything. So whenever you are writing the networks, always networks are going to represent with ones. Okay, so each and every portion is going to carry 8 bits. So you can write down 1, 2, 3, 4, 5, 6, 7, 8 separated by a dot. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot. Host bits always represent with zeros. So here 1, 2, 3, 4, 5, 6, 7, 8. So now we need to count how many host bits we would be required. So here I would be requiring 6 host bits. It is going to depend on the power value what we are using. So whenever you are counting the bits, you need to count the bits from right to left. So here 1, 2, 3, 4, 5, 6. So remaining 2 bits are going to converted into network. So here if I add 8 bits, it is going to become 255. 8 bits, 255. 8 bits, 255. And if I add here 2 bits, so here it is going to become 128 plus 64. It becomes 192. So for group of 64 bits, the subnet mask will be 255.255.255.192. So second step of calculation was completed. So now here we would be requiring third step of calculation. So in third step of calculation, we would be requiring to write the range. So whenever you are writing the range is always written based on the 2 power h value. Okay, so 2 power h. 2 power h is nothing but your h value. So which means group of 64 bits, 64 hosts. Okay, converted power value here. Now you need to figure out how many networks you are going to get. So in order to see how many block of address you are going to get, so you have one formula called 2 power n. N is nothing but here converted network bits. Converted network bits. So this is the formula. So here how many bits I have converted? 2, right? So 2 power 2, which means 4 subnets. So if I write this in rough, so I'll be getting here 4 block of address. So the address starts with 0, multiples of 64 here, the value based on 2 power h range, 64, 64 plus 64, 128, 128 plus 64, 192. So here address ends on 63 because here address starting with 64, and here address ends on 127, and here 191, and here 255. So if I write this in fair, you'll be getting the address 192.168.1 dot and 192.168.1, 192.168.1, 192.168.1 dot, and here also you would be writing the same thing, 192.168.1 dot, 192.168.1 dot, 192.168.1 dot, 192.168.1 dot. So you can write like this also, 0, multiples of 64, 64, 64 plus 64, 128, 128 plus 64, 192. So here address ends on 63, 127, 191 and 255. So this will be your first network. So this will be the second one, and this will be the third, and this will be the fourth network. So 192.168.1 dot will be your network ID, and 1.63 will be your broadcast ID, and likewise here 1.64 will be here network ID, and 1.127 will be broadcast ID, and in this third network 1.128 will become network ID, and 1.191 will be your broadcast ID. In fourth network 1.192 will be your network ID, 1.255 will be your broadcast ID. So for all these networks, the subnet mask will be 255.255.255.192. So the addresses lie between network ID and broadcast ID. These are the valid IP addresses where we can able to assign to our devices. So by using the concept of subnetting, we are going to calculate the network IDs and broadcast IDs. Then we will be getting the valid IP addresses where we are going to assign to our hosts in the network.